Hello, everyone. Great to be here again. Hello from Singapore. So, apology in advance. I caught a cold a few days ago, so my throat is still very itchy, so I might have to cough from time to time. But still excited to be here and to share with you the progress and the planning and a preview of the upcoming Vue 3.6. Okay, so let's get started. So a high-level overview of what's coming in Vue 3.6. The first, foremost, and most important thing is a massive reactivity performance improvement. We'll dig into each of these a little bit later, but here, so first, the reactivity improvements. Second, vapor mode, as many of you have been waiting for. And there will be some major internal types improvements. And finally, suspense stabilization. Okay, so for the reactivity performance improvements, many of you probably have remembered that every past minor version that we shipped, starting with Vue 3.4 and 3.5, we kept improving the reactivity system in Vue because fundamentally it is at the heart of Vue. In recent years, we also have seen a trend of not just Vue, but most other front-end frameworks that is not React have pretty much arrived at the consensus that Vue's reactivity model, which is fundamentally the same thing as the concept as known as signals, is actually an ideal paradigm for front-end development. And it aligns with our mental model really well. So it helps a lot in describing the declarative state relationship in front-end UI. So Vue's reactivity system has a long history. It has pretty much stayed with the same internal concept since Vue 1, right? So in Vue 2, there was some re-implementation, but Vue 3 was the first time it got a major refactor. So in Vue 3, we started shipping proxy-based reactivity. But proxy-based reactivity, i.e. the deep objects, are actually built on top of the lower level primitives, i.e. refs, shallow refs, computed, and effects, reactive effects, right? So if you have looked into the Vue reactivity package, you will notice that there is ref, computed, and effect. These are the three most important primitives of a reactivity system. And in fact, it is most of the other reactivity-based frameworks like Solid.js, Svelte 5, even Angular nowadays, all the Preact signals, all these frameworks and libraries that ship with the concept signals actually has the exact same primitives, maybe with slightly different implementations or APIs, right? So this is also the reason why at TC39 there is actually an initiative about standardizing signals as part of the language, right? So for signals to actually be standardized in the language, still there is a long way to go. So it's probably not going to happen in the next few years. It will take multiple years for this kind of things to eventually reach stage 4 and eventually get implemented by browsers natively, which by that time will likely have the best possible performance. And then we can maybe refactor Vue's reactivity system on top of it. But before that happens, right, there is still plenty of room for us to squeeze out possible performance in this aspect. So Alien Signals by Johnson, who is also the maintainer of Volar and Vue language tools, is an implementation. It started as an experimentation by trying to figure out the best possible performance for Johnson's own use in his projects. But turns out we were able to he was able to actually develop Alien Signals into a version that is able to cover most of the use cases that's needed in the official, not only in the official signals part of it, but also cover the needs of Vue. And he spent tons of work making sure porting Alien Signals into Vue core can pass all Vue ecosystem CI tests. So this is no small feat. And Johnson was able to keep improving alien signals while making sure the ported version into Vue actually can pass all views related tests. So the first PR that got merged was 12349, and it was porting alien signals 0.4.4. So by the time we merged it, it already showed minus 14% memory usage compared to Vue 3.5, which is the branch you are currently probably using. And it shows massive improvements across multiple benchmarks. So this is the graph around the time we merged that PR. So at the top, you can see alien signals. And you can also see many other interesting implementations in the ecosystem. You probably didn't know there are so many different signals implementations. And Vue's reactivity system in 3.5 turns out wasn't actually the fastest, and alien signals is faster by a great margin. And TC39 signals polyphos performing pretty bad in this case. So which is why Johnson actually later on implemented a signals polyfill based on alien signals to help with the standardization process. But turns out he wasn't done yet. Right? So Johnson kept on improving alien signals since so 0.4.4 was the point where we first merged into Vue's development branch. The minor development branch for 3.6. So it is not live in production in 3.5 yet, right? So with every release, alien signals got faster and faster. So in alien signals 0.6, we found another 13.4 performance improvement and 3.4 reduction in memory usage over 0.4.8. And again, so a few weeks later, Alien Signals 1.0 brings another 12% improvement over 0.6. So Johnston has spent countless hours doing micro optimizations, comparing different techniques, different ways of instantiating objects, trying to save memory, save bytes, save computation. So so eventually, when we merge the Alien Signals 1.0 into Vue's development branch, and we can compare this across a big benchmark. So the purple bar, so the text is probably too small to see, but the purple bar is Alien Signals, and the green bars is Vue 3.4. And if so, here we're showing Alien Signals as the baseline of 1.0, and Vue 3.4 is the higher the bar is, the more slower it is compared to Alien Signals. So you can see it is considerably slower compared to alien signals in almost every benchmark. But note this is 3.4. So 3.5 performs slightly better than 3.4, but still compared to alien signals, it's still a massive upgrade. So we're happy to announce that Alien Signals 1.0 has been ported and landed in the Vue 3.6 branch, which is the minor branch on GitHub, in the PR 12570. So if you're interested, do check it out. And also check out Alien Signals, the base library. So we decided that we are going to essentially duplicate the core logic of Alien Signals in Vue core at Vue/Reactivity, so that we're not coupled to the release schedule of Alien Signals as a standalone project, which also gives us more freedom and flexibility to fix Vue-specific issues in case we find other incompatibilities down the road. But Alien Signals is also available as a standalone library that's not coupled to Vue, and actually gives you the capability to define your own reactivity API surface, which is very interesting. And we hope that Alien Signals becoming there is a potential for Alien Signals to become a foundation of cross-framework signal implementation, because it is able to offer the best performance while supporting the signals polyfill. So technically, it should be able to fulfill the needs of most frameworks when it comes to a reactivity primitive. Johnson is doing really important work here, and huge shout out to him for helping us advance in this space. Okay, now vapor mode. So first, a quick recap for those who are not familiar with the concept of vapor mode. Vapor mode is a new compilation strategy for Vue. So the core idea is you write the same source code, but Vue compiler will compile it to different compilation output, something that's more efficient, which means with the same API, with everything you've already learned, you get better performance and less memory usage with nothing new to learn, really. Um, so Vapor Mode allows Vue's rendering performance to reach the level of Solid.js, which is known for having probably the best rendering performance among all well-known frameworks nowadays. And it is also, also, most importantly, compatible with existing code bases. So it allows you to perform piecemeal migration or opt in, sorry, or opt in, selectively opt into vapor mode only for the parts that are performance sensitive in your application. Um, so when it comes to vapor mode, it is important to think from a high level perspective because it is essentially the next step of Vue's rendering strategy evolution. If we look at how Vue evolved over time, during the times of Vue 1, we actually used a DOM based templating strategy where we will take a string template, instantiate it as inner HTML, essentially create real DOM nodes out of it. Then we will walk that real DOM tree to find the bindings as actual attributes and then create reactive bindings on the actual DOM nodes. So this is how Vue 1 worked. In Vue 2, we opted into pure virtual DOM. So the compiler will take the template and compile it into virtual DOM render functions. And then we ship a virtual DOM runtime that is able to compare and diff the virtual DOM trees, right? So the reason we opted into virtual DOM was mostly because it was the most straightforward way for us to also achieve server-side rendering, which was one major new feature in Vue 2.0. But as later on, many have realized virtual DOM actually adds quite a bit of overhead in terms of memory pressure and the cost of diffing. So it doesn't always lead to the best rendering performance. So in 3.0, due to compatibility concerns, we still shipped with virtual DOM, but we used the compiler a bit more to enhance it. So Vue 3 most notably shipped with a much more powerful compiler, which allows us to perform more static analysis during the compilation phase to generate a code that performs better at runtime. So this allows us to essentially fine-tune the generated code, the generated virtual DOM render functions. For example, we can leave compile time hints. We can generate what we call virtual DOM blocks. We can generate vnode patch flags, which essentially are hints that's left for the runtime to take fast paths. So this approach allows Vue 3's virtual DOM to actually perform significantly better than Vue 2's pure virtual DOM. However, there's also a limitation to how far it can go with virtual DOM optimization because regardless, you still need to create tons of virtual nodes, and that creates memory pressure. And you still need to walk through the virtual DOM tree, although you can skip over some of them. There is a limit to how much you can optimize in this direction. Moreover, because of these fast path hints, it makes our compiler more complicated because we are always thinking about. It also makes the runtime more complicated because we're always thinking about two code paths. One code path is the pure virtual DOM code path, which can be non-optimized case or manually written render functions. So this is less performant, but the logic is more straightforward. The fast code path usually depends on compiler-generated hints, but it's a different code path. So we essentially always have to think about, is this in the current pattern phase, are we in optimized mode or non-optimized mode? This creates tons of complexity for the runtime. A lot of extra code needed, which cannot be tree shaken. It also leads to potential pitfalls, more bugs due to optimization. So there's definitely downside of this approach too. So vapor mode is essentially trying to get rid of virtual DOM altogether. Instead, we try to generate code that aligns with the possible code, most optimal code that you would have written by hand. For example, if the template describes a button containing a piece of dynamic text, right? So if we were to write this, render this interface using imperative APIs, we would say, well, create a button, then set its text. Uh, so if the text comes from a dynamic ref, we will use a watch effect to essentially set that text so that whenever the text changes again, we will set the text again. So this is how we would think about it if we were to write the API or write the code ourselves imperatively. And that is, in fact, exactly the type of code that Vapor Mode tries to generate. So it tries to generate code that essentially is the most direct way of achieving what the result you want to see on the screen, while leveraging Vue's current reactivity APIs. So there is another talk tomorrow by our team member, Little Sound, Rizumu, and she's going to be doing a whole talk that's more focused on the philosophy and some compilation details of Vapor Mode. So make sure you tune into that. So Vapor Mode currently, the development, previously we had a separate repository called Vue Vapor, which was largely under development because we want to separate in the early phase of it, we want to separate the pull requests and issue lists from the main repo, just so there's less noise and allow faster iteration. But we've got to a point where majority of core features has largely been done. So we feel it's time to move the development back into Vue core so that we can integrate better into the same repository's infrastructure and CI pipelines. So the latest Vapor Mode development is now happening in the core repo under the Vapor branch. And there is an open PR in case you want to see the changes, the diffs. It's a massive PR. There are hundreds of commits in that PR, and there's still tons of work to do. But if you're interested, check it out, and we're welcoming any sort of participation and contribution if you're interested. So in December, in the past December, we did another big push on Vapor Mode. So this time we focused mostly on the component model, which was a part that was not very well optimized in the previous implementation. So essentially, we redesigned the component props slots handling to make it initialize lazily. So this vastly improved component instantiation cost, which is another aspect of Vapor Mode, right? So the compilation strategy itself makes the updates inside each component itself extremely efficient and fast. However, when we when we create a huge application, another aspect of cost comes from creating component instances. This is one area that we always wanted to improve in Vue. And Vapor Mode gives us an opportunity to rethink how it works. In virtual DOM, it is really hard to change the way props works now because there are too many implicit behavior depending on how props are tracked when components are updated. But in Vapor Mode, we have changed all the props passed to child components to be lazily accessed, which means when you pass a prop into a child component, it is passing as a func, which is a function returning the actual value. So if you're passing a ref value down into a component, the ref value is actually not accessed until the child component renders itself. So this makes that ref the dependency of the child component, which actually makes the whole update graph more accurate So when you mutate that ref in the parent component, only the child component updates. This might be a bit abstract, but we will come up with some more detailed examples to help you understand when we are closer to release. But to put it in easier to understand terms, component instances in Vapor mode are much cheaper to instantiate. And in a benchmark, we are able to mount 10,000 components. Just checking if the number is correct. Actually, it is. Sorry, it is actually 100,000 components. I need to edit it right now. Underestimated our performance. 100,000 components mounted in 100 milliseconds. That's how efficient it is. So another big part of the refactor is we refactor the whole Vapor mode implementation to use a shared current instance between VDOM and Vapor. So there will be virtual DOM component instances and Vapor instances in the same tree because that is the goal. We want to allow per component update, which means the most common use case will probably be a Vapor to have a virtual DOM based application running mostly virtual DOM components, but you can have Vapor components taken over a subtree of it for in cases where it's extreme performance sensitive. Or you can have a whole Vapor component application that is Vapor only. But we also want to allow Vapor components to contain VDOM components. So in theory, eventually there might be a mixed virtual DOM and Vapor component trees, which means they need to be able to share the same. So the concept here is there are many utilities in the Vue core code base, like lifecycle APIs, providing inject, prompts validation, error handling. They don't really care if a component instance is virtual DOM based or Vapor based. And they should be able to work across the component graph that a component tree with mixed instance types. So essentially, this is exactly what this big refactor achieved is now all these internal APIs work on a shared type called a generic component instance. And so you can use the same unmounted hook API in virtual DOM components or in Vapor components. They work the same way. Same for error handling, providing inject and props validation, etc. And finally, we also added HMR support. So that you get the same nice development experience when you're working in Vapor mode. So there are still a lot of things we need to finish, but in 3.6, we want to ship Vapor mode in a way where people can start using it without going through complex setup configurations. So essentially, the experience will be like upgrade to Vue 3.6. Nothing changes in your application. But now, if you take a component and change script setup to script Vapor, that component will be compiled in Vapor mode. Alternatively, if you start a brand new project with Vue 3.6, you can create your root app with create Vapor app, which will create an application instance which assumes to be Vapor only. So apps created this way doesn't pull in any code from the virtual DOM renderer, the virtual DOM runtime. So it will result in much smaller bundler size. To clarify, if you have a virtual DOM-based app today and you opt into Vapor mode, the total bundle size will get slightly bigger because you're pulling additional Vapor runtime code. But due to the refactor we did, Vapor is able to reuse a lot of logic with runtime core. So the size increase will be very negligible. So probably around something like 3 to 4 kilobytes. There are features that will not be supported when we ship Vapor in 3.6. That is SSR hydration, transition, keep alive, and suspense. So we will complete this in future minors as we improve Vapor. But the most important thing is we want to get Vapor into the hands of developers, let people start playing around with it, and help us find issues, stabilize it over time. So then there are the internal type improvements. So right now, Johnson, again, is working on a simpler implementation for the define component type, which is the single most complex type in the entire Vue code base. Um, if you've never touched the Vue source code, you probably don't really know what this entails, but I would recommend you go to GitHub, clone the code, and just search for define component type and look how many lines of types that is. There are like 5 overloads. Each of them are uh, leading into more generic types with dozens of generic arguments. So it's a beast. And Johnson is working on trying to simplify it. And the significance of this is a simpler defined component type may be able to help us improve Vue type checking performance. Because when you use the Vue language tools, uh, every code completion and type inference you see when you're using Vue SFC with language tools has to go through defined component. So the performance of this type can be can have a large impact on the overall type checking performance in especially in large projects. So to sum up, 3.6 will bring Vue's performance to another level because thanks to adding signals, Vue 3.6 will have an S-tier reactivity system. Thanks to Vapor Mode, it will have an S-tier rendering system. So, and reactivity and rendering combined together is essentially the whole framework. So the whole framework actually gets a huge boost in terms of performance, uh, while also allowing for smaller bundle size. So if you're using Create Vapor mode, Create Vapor app to create a Vapor only app, you will have a project with less than 10 KB baseline size. Okay, so that is Vue 3.6. I'm not sure how much time I have left. But I can quickly go through a few other important ecosystem updates outside of Vue itself, because people probably are interested in what we've been working on at Voice 0. So, Rolldown. We shipped Rolldown 1.0 beta again in December, and really encourage people, especially if you have existing project that's using Rollup or ES Build, Rolldown can actually now serve as a capable replacement of both. So Rolldown's performance, when we this is bundling 19,000 modules with 10,000 React.js components and 9,000 plain.js files. As you can see, we are not even comparing against any JS bundlers at this point. We're only comparing with ES Build, which is written in Go, and Farm and RS Build, which are written in Rust. And we are at least 3 times as fast as other Rust bundlers, and significantly faster than the ES Build. But this benchmark was taken on a Linux machine with many cores. On Mac, it seems we're usually on similar performance with ES Build, most of the time slightly faster. But another important thing is Rolldown has amazing WebAssembly build performance. So this is important when we do things in browser environments. For example, in web containers, aka also, which means like web containers. So not just in custom web containers tutorials or online IDE environments, but as an example, StackBlitz probably is the most well-known example of online IDE that's using web containers. Right? Rolldown running in StackBlitz environment is able to bundle 2.5 thousand modules in 0.6 seconds. And surprisingly, ES Build, which is known for being fast, actually has a problematic WASM build that performs even worse than JS bundlers. So this is significant because when we get Rolldown into Vite itself, all Vite builds inside StackBlitz will also become significantly faster, which means when you use Bolt New, the AI service that's based on StackBlitz, right, all the projects will also scaffold and build blazing fast. Another area of improvement is the OXE minifier. So for a very long time, the minifier was in a prototype state, but Boschan has been working on actually making the minifier complete in the past month, and we're making great progress. As you can see in this benchmark compressing Three.js, OXE is able to achieve very close proximity compared to Tensor and SWC, just 1% difference in terms of compression ratio, better compression ratio than ESBuild, and the fastest performance among all of them, which is more than 5 times faster than SWC, um, which is also written in Rust. So this will also be the built-in minifier for Rolldown. So the performance will be amazing when we actually land this. So Rolldown Vue progress. An overview of the test cases. So Vue's own test suite using Rolldown is pretty much all passing. The 3 failing cases are all really edge cases, and we know how to fix them, but they're just not prioritized because these are really very few people will actually be affected by these. So we're focusing on the ecosystem CI right now. So we have 11 out of 28 tests passing, with 5 additional passing with minor issues, 9 failing. 6 of them we already know where the problem is, and we're working on those. And 3 skip because they're failing on Vue's own ecosystem CI too. So our goal for the next coming 2 months is to get as many of these ecosystem CI tests passing so that we can ship a version of Rolldown Vue into the hands of our users to test it out in real world projects. Okay, so beyond ecosystem CI compatibility, the Rolldown Vue roadmap includes full bundle mode, which addresses the dev server startup performance issues with HMR and incremental build. And we're also working on module federation, which is a requested feature by many people who are stuck on Webpack. And we also intend to use Rolldown to power environment APIs to replace the current SSR transform, which is JS-based, which should greatly improve the performance in full-stack apps during development, because now the server-side graph will be handled by Rust instead of a JS transform. And also, there will be no more SSR externals problems, because everything can be just bundled, because Rolldown is that fast. So check out our latest roadmap here in the link. It is in the Rolldown discussions issue 153 to keep updated on the latest progress. And that's it. Thank you.